Here we gathered all the data. Here we defined that we want to have such a variable. Now we can go to new user and store a value in that variable. And then here create an instance of our struct by repeating the struct name, user, and then adding opening and closing curly braces thereafter. And between those curly braces, we now insert the data that should be stored in the struct. And we got two ways of doing that, to be precise. We can either repeat our field names like first name and then add a colon, but no equal sign, just a colon. And then after the colon, define the value that should be stored in that field. In this case, first name, this variable. So on the right side of the colon, I'm referring to the value that should be stored, and that's the value stored in this first name variable. On the left side of the colon, I'm referring to that field name where that data should be stored. And we can now repeat that. We can add a comma-separated list of all our fields here and also target the last name field and store the last name variable value like this. Target the birth date field and store the birth date variable value, a birth date written like this with a lowercase d because that's the notation I chose here, also to show the difference between left side and right side. And then we can add the created date field and store the created variable value in there. And that's how we can now create a concrete instance. Now, since this can get a bit hard to read, you can also split this code across multiple lines here. So you can also write this like that. And then hit the auto format shortcut. It's important that you have a comma after the last key value pair as well then, if you want to split this across multiple lines. And now we have a very readable way of creating a new instance of such a user data structure. And now that's what's stored in the new user variable. Now with that, instead of outputting all these individual pieces of data, we can refer to our new user variable now and try to output that. And that's what I'll try now. I'll save everything and then open up that terminal again, run this application again and enter some quick data like that. And we see that we get this kind of output here now. It's a bit different from what we saw before, especially that date thing here looks a bit different, but generally this is working and we are outputting our data, our new user data now. And the advantage is that we now have this data package, new user, which contains that grouped together data. And if we have a bigger application where we now also maybe have a function that saves user data to a database, we can just pass that entire new user struct to that function instead of passing the individual variables. And that, of course, can save us a lot of time, a lot of errors, and make code maintenance a lot easier in bigger applications. Now, there is more than one way of creating a concrete instance of our struct blueprint. And that's, by the way, important. We got the blueprint here, where we define our own type, and then we use that type to create a concrete instance of it. And that's what we're doing here. Now, there are a couple of ways of creating a concrete instance. Here we are using the struct literal way of doing it by using the struct name and then curly braces and then adding those key value pairs of our fields and the values for those fields. There are also other ways of using that struct literal approach though. For example, if you plan on keeping the order which you define here, so first name, then last name, then birth date, and then created date, as I'm doing it here, then you can omit those key names here. You can remove all those key names here as long as you keep the order. So that is then also fine. And then we could also move it back into one line if that's easier to read for us. Here I'll keep it split out across multiple lines. And that's of course a bit shorter, so that's something you might want to consider. You can also omit all those values if you want to. Now I'm just getting an error here regarding those variables because I'm not using them anymore, but creating an instance of the struct like this is also fine, but of course it will be an empty instance. It will basically be a struct with all those fields, but all those fields are initialized to their default null values. So for example, to an empty string here. And therefore that's of course very often not useful, but sometimes it can also be useful to create it like that. Now you can also, if I go back to the approach from before, where I do include the key names, omit individual key value pairs. For example, now I removed last name, but I have all the other values and I'm setting all the other fields. Now all those fields will be set to those values I'm assigning, and last name will simply be set to the default null value, which is an empty string. So you got a lot of flexibility regarding that. What's also done very often is that you create a helper function for creating a struct, so that you outsource the logic of doing that here to another place in your code. That can especially be helpful if you have a more complex way of creating such a struct instance. And I want to show that to you as well. I'll add a new function, and I'll add it right below the struct definition so that we always see that. And I'll name it new user. And this will be a function that's only responsible for creating new user struct instances. And the convention for naming that function then is that you have the word new in your function name and then the name of the struct that will be created, to make it clear that this is a function that will be responsible for creating new user structs. And here we could then, for example, say that we here expect to get the first name, and I'll just name it fname here, this parameter. It is, of course, up to you, that parameter name. That we get the L name, so the last name, and the B date for the birth date. I'm not getting the created date because I will now actually create that date inside of that new user function. So in that function, I now have my user variable, which I create here, and I use the user struct literal here to create a new instance of that struct. And I'll set first name to fname here, and I'll set last name to lname. And unsurprisingly, I'll set birth date to B date, like that. And I'll set created date equal to the current timestamp. And for that, I'll actually take that timestamp creation here from the main function and remove it from there, because we can argue that it is a process that's only related to the creation of a new user struct, since we only use the timestamp there. And hence I'll put it into this new user creation function here and get my current timestamp here and then use that variable here for storing that created date. And then of course here in new user we can return this user struct variable here and make it clear that this function will return such a user by adding our struct type as a return value type for this function. And now we got this helper function which we can use from anywhere in our code if we want to create a new user struct instance, so that we don't have to use that struct literal code in those places. So here in main, instead of using the struct literal notation here, I can now just call new user, so this function which we added, and then pass my first name, my last name, and my birth date to that function. And now we again will have a new user if I save that and if I would run this code. So that's yet another way of creating such a struct instance. Of course, we're still using the struct literal notation, but we outsourced it into a separate function, which also does some extra work. It gives us this timestamp, and we can conveniently call that function from anywhere in our main code whenever we need to create a new user struct instance. And of course, that's still our goal. keeping that main function and all our functions in general lean and focused on a specific task. And now we do have a function with the specific task of creating a new user instance.